All right, here we go. Let's go through this since some of you are having a little trouble. So we're outside. Our divisor is that. Okay? It's a trinomial. Inside, our dividend is 2x to the fourth. Remember, if there's an x to the fourth, what else has to be there? X to the third. So it's not there, so you have to add 0x to the third. Also needs to be what? A 0x squared, right? And then the other ones. Oh. I didn't know you had to do that. Yeah. Yeah. I did marking maps with that. Whoa. Yeah. No. I know that. Yeah. That's pretty cool. All right. All right, so then we do the minus 5x plus 4. So, you guys in the back start paying attention. All right, you have to put those because an x cubed will show up and an x squared. Same thing goes if you have it out here. If this 3 minus 3x wasn't there, it was just x squared plus 2, you need to put a plus 0x because those spots will show up. When you do this now, the actual division part is really easy. It's just a monomial divided by that monomial. Okay, you don't worry about the other stuff as far as the division goes. So what's 2x to the fourth divided by 1x squared? 2x squared, right? All you're doing is subtracting the exponents. Now what do I do with that 2x squared? What's the procedure? Multiply. 2x squared by all three of these terms out there. So I go 2x squared times the x squared, which is 2x to the fourth. 2x squared times the negative 3x, which is negative 6x cubed. See, an x cubed showed up. I've got that 0x cubed there. It's lined up with like terms. And then I do 2x squared times 2, which is 4x squared, and also have a 0x squared there that I can line up. Now, what's the next step in the procedure for long division? Subtract them all, yes. And 2x to the fourth minus 2x to the fourth cancel out. 0x cubed minus a negative 6x cubed is actually positive 6x cubed because minus a negative is addition. And then 0 minus 4x squared is a negative 4x squared. Now, what do you do before you divide again?
Bring down the negative 7.
Right, bring down the negative 5x. Drop that down. And then you just start over. Again, it's this monomial 6x cubed by that x squared. All right? So what's 6x to the third divided by 1x to the second? 6x. That's an easy math problem, right? And that's positive. Now I do the same thing. I take that 6x and I multiply it by all three of those. So 6x times the x squared gives me the 6x cubed. 6x times the negative 3x is negative 18x squared. 6x times the 2 is a positive 12x. And then again, we're going to subtract. So we just keep repeating this process. 6x cubed minus 6x cubed cancel out. Negative 4 minus a negative 18 is the same as negative 4 plus 18. Jordan.
I think it's a negative 18x squared again.
6x times negative 3x.
Okay.
I'm distributing that number I got when I divided by all three terms.
I think it's
I divided 6x cubed by 1x squared. You're welcome. So negative 4 plus 18 is 14. Right, Nick? Negative 5 minus 12 is negative 17x. And then bring down the plus 4. And we divide one more time. What is 14x squared? This monomial divided by 1x squared. 14. Okay? And again, I take that 14 and I multiply it by the x squared. I multiply 14 times negative 3x, which is what? Negative 42x? Oops, not 14, 42 is what I said, wasn't it? And then 14 times 2. And then I subtract again, one last time, because there's no more that I have to drop down. Whatever I have down here now is my remainder. So I have minus a negative again. So I'm adding. Negative 17 plus 42 is what? 25x. And then 4 minus 28 is a negative 24. So I write my remainder over whatever I was dividing by. So this is x squared minus 3x plus 2. So we had to add some zeros to hold those spots. If you don't do that, things don't line up nice like that. Okay? Any other questions about that problem? Okay, so your answers to your 4 homework problems. Number 2 worked out nice, 3x plus 1, no remainder. Number 4 is 7x plus 1, and then our remainder is negative 6x minus 1 over x squared plus 1. You have to add a 0x outside like we had to on this one. But it was on the outside part, not the inside part. You had to add a 0 on the end for number 4 underneath and a plus 0x after the x squared out front. Number 6 is just 5. And then you have this big remainder. 25x squared plus 5x minus 11 over 2x cubed minus 4x squared minus x plus 2. So for number 6, some of you had trouble with that. You had to put a 0x underneath. And then all you could do is do that one division problem. 10x cubed divided by 2x cubed is just 5. And then distribute your 5 through, subtract, that's your remainder. So it really was pretty easy on number 6. Number 8, you're going to have to add an x cubed and an x squared, just like we did on this warm-up. And your answer is 4x squared plus 12x plus 44. And then your remainder is 161x plus 84 over x squared minus 3x minus 2. Any of those you'd like me to go over? 2, 4, 6, or 8? The warm-up helped?
Yeah.
So we're good on long division.
Hopefully.
All right, today is called then synthetic division. You'll like this a lot better. It's a lot quicker. It's a shorthand method. All right? Well, there was our problems. All right, so let's pay attention. Okay, Caleb?
Yes.
Thanks. So it's a shorthand method of dividing a polynomial by a linear binomial. We use the coefficients only. It says for synthetic division to work, the polynomial must be written in standard form, just like we did for long division, using 0 and a coefficient for any missing term. So if there's an x to the fourth in this problem for synthetic division, and there's no x cubed, we got to put a 0, just like we did before, okay, when we do these. The divisor must be in the form x minus a. It's going to be x minus 2 or x plus 2, x minus 5 or x plus 5. It's going to be just a binomial we're dividing by. It won't be any trinomials like we did on long division, okay?
He likes him.
Yeah, that's true. All right. So here's a division problem. You can see up there at the top, 2x squared plus 7x plus 9 divided by x plus 2. Okay? So I'm just going to rewrite it here. 2x squared plus 7x plus 9. Well, we're dividing by x plus 2 or my plus 2. So here's our binomial, x plus 2. It's always going to be something that easy. It's not going to be anything bigger than that. Just a 2-term binomial. And it's usually just 1x plus something. Okay? All right. So here's what we do. We make a little corner box. And whatever makes that equal to 0, we put in that box. So what value of x makes x plus 2 equal to 0? Negative 2. So that's the first thing you got to remember. If it's x plus 2, your little box is negative 2. If it was x minus 2, what's in our box? Positive 2. Okay? Now we use these coefficients. The coefficient of x squared is 2. The coefficient of x is 7. And the constant is 9. Nothing was missing. All right, so I didn't have to add any zeros. Okay, but in that top row of numbers, sometimes you're going to have to add a 0. If we started with an x to the fourth and then there wasn't an x cubed, we'd have to put a 0 in that spot. Okay, don't forget that. Give yourself a little room under those numbers and make a line, because you're going to write numbers above and below that line. So just give yourself some room to write numbers. All right? And we're going to drop down the first term instead of the last term like we did in long division. So that's the setup to start a synthetic division problem. You don't have to write out any variables like we did for long division. Okay? Now, just like we did in long division, once we figured out what an answer was when we did that division part, we multiplied, right? We go back to the warm-up. Once we figured out we got this 2x squared when we divided, we said 2x squared times 1x squared, and then we did that multiplication, right? Well, that's what we're going to do here. We're going to multiply. Oops. Down here, right? I'm going to multiply negative 2 times 2, which equals what? Negative 4. That answer goes above the line under the next number. All right? So I went negative 2 times 2 to get that negative 4. Now, in long division, we subtracted. In synthetic division, we're going to add the numbers. So what's 7 plus negative 4? Positive 3, right? And then we just start over. What's negative 2 times 3? Negative 6. That goes above the line. And then I go 9 plus negative 6, which is 3. All right, this number here is always the remainder. Okay? That's going to be the remainder of our problem. Okay? Now remember, this first 2 was 2x squared, right? When you do synthetic division and write your answer, the variable is always to the 1 less power. So this is 2x to the first plus 3, because it was a positive 3. If that's a negative 3, I'd write minus 3. And then my remainder, I just put plus 3 over x plus 2. It's that quick. Yeah, I knew you guys would like that.
I couldn't leave the apple part.
Because you got to feel the pain of long division, too.
No.
Then you appreciate synthetic division.
I'm not gonna feel that.
Questions on any part of that? All right, let's do another example. All right, so I got x plus 2 again. So what's in my corner? Negative 2. We good? We all understand?
Yeah.
Since it was x plus 2 again.
Yeah.
I don't know why they should have given us another number, but they didn't. It's okay. So I got a 3 for the x to the 4th. I got what number for x cubed? Negative 1. What's missing? X squared. So what do I put there? 0, yes. Then the 5 for the x, and then the negative 1 for the constant. If that negative 1 wasn't there, what would I put in that spot? 0. Okay? Even if the constant's not there, put a 0. Okay? Make your line. Drop your 3. Questions on setting it up? All right, go ahead. Finish it. That's a 1, that's a 0, that's not a 10.
Pretty cool, huh?
All right, sounds like you guys got it. Okay. All right. So what's Nick? Watch. What's negative 2 times 3? Negative 6. What am I supposed to do with those two numbers? Add. Right. Negative 1 and a negative 6 is a negative 7. Negative 2 times negative 7 is positive 14. Right. What's 0 plus 14? 14. What's negative 2 times 14?
Negative 28.
Negative 28. What's 5 plus a negative 28? Negative 2 times negative 23. Yep. All you gotta do is watch, right? It's positive 46. Negative 1 plus 46. 45. 45. So what did we start out with? X to the fourth. So this 3 is 3x to the what? Third. Always one less in your answer when you write it. Got that, William? One less. So 3x to the third minus 7x squared plus 14x minus 23. And then that 45 is our remainder. So 45 over x plus 2. Now a lot better than long division.
Yeah.
Makes it a lot easier, doesn't it? Okay. So what goes in my corner? You guys talk me through it.
Positive 6. Positive 6.
What's my numbers?
1. Negative 3. Negative 18.
1 minus.
Did I have to add any zeros?
You did not.
No.
Just the numbers in front of you. Yellow column.
All right. So what goes above the line?
6. 6.
Below it?
Negative 3. I mean 3. Negative 3.
3. Above the line?
18.
Below?
0.
That's nice. No remainder, right? So what's my answer?
1x.
X plus 3, right? No remainder. So, is that true? Is x minus 6 times x plus 3 equal that? If I FOIL it, will I get that? Yeah, it would, wouldn't it? We could always check if you wanted. You don't have to check, though. First, outside, inside, last.
Wow.
Okay? So when there's no remainder, let's think about this. If I start out with that trinomial and then I get x minus 6 plus x plus times x plus 3, what did we call those with respect to that? Did we call them factors?
Yeah.
Right? If I asked you to factor this trinomial, you'd give me that, right? Those two binomials. Okay? So if the remainder is 0, that means that these two terms, or these two binomials, are factors of that polynomial. All right? Just something to think about as we move through this stuff. Okay? It says you can use synthetic division to evaluate polynomials. This process is called synthetic substitution. The process of synthetic substitution is exactly the same as the process of synthetic division. So you're just doing synthetic division. But the final answer is interpreted differently, as described by the remainder theorem. If the polynomial function p is divided by x minus a, then the remainder r is p of a. Meaning, if we're doing p of 3, if you just had this polynomial and I asked you for this, what do you do with the 3? You plug it in for x, right?
Yeah.
So if I plug 3 in for x, I'm going to get 7. But you could also put 3 in your little box and do synthetic division, and whatever the remainder is the answer. So that's what they're asking you to do. Do synthetic division, whatever you get for the remainder, that's the answer to the problem. You don't have to write out the long answer. Okay? Now, when they do this, they usually don't write x plus 2 or x minus 2 or x plus 3 or x minus 3. They just tell you what x equals. Okay? So it says x equals 2, so what goes in my corner? 2. Don't do the opposite. Right? Because it said x equals 2. You with me? If it said 4x minus 2, then you put 2 in, right? Or if it said 4x plus 2, then you put negative. But this says 4x equals 2, so don't switch it like we just did. That's where we make a mistake sometimes, okay? So pay attention. What goes first? 2, then what? 5, then -1, and then 7. So we do everything the same. What's 2 times 2? 5 plus 4. 2 times 9. -1 plus 18. 2 times 17. 7 plus 34. What's my answer? 41. That's the answer. So you don't have to write that long 2x squared plus 9x plus 17 plus 41 over x minus 2. You just tell me what the remainder is. That's the answer to the problem. When you do synthetic substitution. Okay? Simple, right? We need to do another one?
No.
Even if it's a fraction, can you handle it?
No. You can do it. You got it.
All right. Let's go ahead and do it. So I got a 6 for the x to the 4th, -25 for the x squared, or I'm sorry, x cubed. Is there an x squared? No. So you got to put a 0 in this one, then the -3, and then the 5. So what's -1/3 times 6? -2, yeah. Just put that in your calculator. -1/3, parentheses, times 6. Or you can just, basically you're dividing by -3 each time, aren't you? Isn't that times -1/3 is like dividing by -3? So anyway, that's a -2. Add those, you get -27. What's -27 divided by -3? +9, right? 0 plus 9 is 9. What's 9 divided by -3? -3. Add those, you get -6. We did the +6 and got -2. So what's -6 times -1/3? +2. What's 5 plus 2? What's the answer to the problem? 7. Simple. All right, that's synthetic substitution, right? All right, there you go. Good job today. That's the last thing we're going over for this quiz. We have a quiz Thursday. Quiz Thursday, sections 4.1, 4.2, and 4.3.
Hey, we find one for these. Yeah,